As with any ranking question, we want to read it carefully and then decide what criteria we're going to use to base our rankings on. So in this question, we're looking at samples of copper, aluminum, and water. And the key is they all experience the same temperature rise when they absorb the same amount of heat. So two key pieces of information there. Same temperature rise and same amount of heat. Next, we read that the question provides us with the specific heat capacities for copper, aluminum, and water. Another key piece of information. Finally, if we read the actual question, it wants us to rank the materials according to mass, starting from that with the highest mass. Now let's continue on by identifying what information is given. They all have the same temperature rise. So when we talk about change in temperature, it's the same for each. They all absorb the same amount of heat, and in physics we use the symbol Q. In physics we use the symbol Q for thermal energy. We want to rank them according to mass, small m, and they give us all the individual specific heats, which is little c. So we know the equation immediately when we look at all the given information. The heat energy, or thermal energy, is mc delta T. And now we want to decide how we're going to organize it. It would be useful to put all of our constants onto one side of the equation. We know that Q and delta T are identical for all of them. So if I divide both sides by delta T, I get Q over delta T is mc. So what that means is that m times c must give a constant value for each item. Now we also know the specific heats for each item. Water being the highest at 4,186, copper being the lowest at 390. So we can see from our equation, if we want m times c to remain constant for each mass, then as c goes up, m must go down. In other words, if c is large like it is with water, the mass of the water must be small to maintain that constant. So this might represent our water. Now if c is small like the copper, the mass would have to be quite large to compensate, to maintain that constant value. And obviously the aluminum would be somewhere in the middle. In other words, what we have is an inverse relationship. Mass is inversely related to the specific heat. So if I solve my initial equation for mass, I get mass is some constant divided by c, or as I already previously stated, mass is inversely related to c. If c goes up, mass must go down, and vice versa. So if we're going to rank them, our largest specific heat, the water, will have the smallest mass, and our smallest specific heat, the copper, will have the largest mass. So our rankings will look like this.